So the last thing I want to do in this chapter is just make some explicit connections between some of the formalisms in kinetics and those of equilibrium. And I've alluded to both in both chapters so far, but I haven't made it super duper abundantly apparently clear, and I just want to do that really quickly. So for that, we'll just use the generic reaction A plus B goes to C plus D, and let's try to write up a rate law for the forward and the reverse reaction here. So that should look like something like this. And we've already talked about back when we were discussing mechanisms in kinetics that equilibrium is defined as when the forward and the reverse reaction rates are equivalent to each other. So we could set these two things equivalent to each other. And what does that get? The equality that looks like this when we're at equilibrium, so forward and reverse are identical in rate. So we can do a little bit of rearranging here and get the rate constants on the left side and the concentrations on the right. Uh-oh, and it is starting to look like something we are familiar with. So the right side of this equation now is the products raised to their respective powers over the reactants, which we know already to be the same as big K, or the equilibrium constant. So what can we conclude about Kc? Well, Kc is a constant, the equilibrium constant, that is also equal to the ratio of the rate constants, and that really brings the whole picture together. So these things are intimately related to each other. It's important to know, because this can be a little confusing when you're first making these connections and learning about it. At equilibrium, the rates are equivalent to each other. That's what we've highlighted here, right? The rates are equal to each other. But that does not mean the rate constants are equal to each other. That's a distinctly different situation because the rate constants, the ratio of which is the same as K. This is going to be really useful because now you can sort of use both your kinetics understanding of rates and the extent of reaction equilibrium and equilibrium constants to really fill in the full picture of these chemical reactions.